In this video, we're going to take a look at example number 6. Let's see what it says. Consider the following data sets. I want to create a scatter plot, normal probability plot, and residual plot to determine if it's reasonable to assume a linear relationship between the variables. And if there is, then I should find that line of best fit. Okay, so let's take a look at part A and see what we have. The Gallup organization regularly surveys adult Americans regarding their commute time to work. In addition, they administer a well-being survey. The data below is for 7 individuals. So I see over on the left I have recorded people's commute times, how long does it take them to get to work, and then their score on this well-being test. Okay, and I'm curious if there's maybe a connection. So the first thing I'm going to do is to attempt to create this scatter plot. But before I do that, I want to make sure that the calculator knows that we are working specifically with these new numbers. So if I go to my calculator, the first thing I want to do is to make sure I have these numbers entered into a list. Now, as you can see over here in my list 5 and 6, I've already entered these values. I would ask you to go ahead and pause the video so you can enter your values, and then hit unpause to see me work through the rest of the problem. Okay, so once I have these numbers actually plugged in, I want to make sure that the calculator knows that these are the lists that I'm using, and I'm not using any of the previous lists from any of the previous problems in this section. So if I was to go ahead and click on Stat, go to Tests, and run my linreg-t test specifically with these lists, number 5 and 6, the calculator will know that these are the lists that we're talking about and trying to use on this question. I don't have to care about any of the other information here. I don't even care about what numbers this spits out. I just needed to do that to update the list that the calculator is referencing. Now I can go ahead and attempt to kind of create my scatter plot. To do this, I can go ahead and go to my second, y equals, go into my first option, and you can see here I already have set up how to make a scatter plot. I'm going to click that first option, and I'm going to do list number 5 and list number 6. To see that picture, I'll go ahead and I'll click zoom 9. Now in my picture, I'm also getting my line of best fit that's coming right in with it. And if you have that as well, that's great. If you don't worry about it, because I didn't ask you to draw the line of best fit. I just asked us to go down here and try to sketch out what that scatter plot looks like. So I'm going to go ahead and sketch out a rough picture of that scatter plot. Looked something kind of like this, right? And so I could even see again that line of best fit that was kind of zooming through it. Looked something, I don't know, kind of like this. Let's just say it looked, yeah, roughly like that. Perfect. Okay, so now that I have this scatter plot, again, you don't have to draw that line of best fit. I want to now create a normal probability plot. All right, to do that, remember that I would go back to my y equals. I'm going to go ahead and change to this last option down here, and I want to change my list to a residual list. So I'm going to click on second and the stat button. I'm going to go to my residuals list, and then I can go ahead and hit zoom 9. Now if you don't get a picture like me, it's probably because you didn't update the calculator to be working with list numbers 5 and 6. But if you did, you should get a picture that looks like this, and I'll record this on the page as well. So I got something that looks like this, and then this, and then this. And again, this is supposed to be roughly linear, and so I'm feeling pretty good about this picture as well. Over here, I have a roughly a line. Over here, I also have roughly a line, which is what I want. Now in a residual plot, remember that there's going to be this horizontal line that kind of stretches across the middle. Oops, oops. That's not what I want. I want to move that up a little bit. Can I move that up? I cannot. Okay. We'll leave it there. But there's this line that kind of comes across the middle, and I'm going to have dots kind of occurring on either side of it. If I go back to my calculator to make this picture, remember that I have to change back to my first option, and I want to change this to my L number 5, that's where my x's were, and my y's should be my residual list. Okay, so if I hit my zoom and my 9, I get a picture that looks like this. All right, if I was to go ahead and sketch that, that means I get something that looks like this, 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 something over here, and over there. So I want to go ahead and go through each of these pictures to see if it is, again, reasonable to assume a linear relationship between the variables. So again, in the scatter diagram, I'm looking to see if the data looks roughly linear and has no outliers. And this seems pretty good. So this here is roughly linear. So this feels great, right? I'm going to check that off. Down here, I want something that is, again, roughly linear. So that seems good. I can check that off. Remember that in the residual plot, like we talked about in the last video, what I'm looking for is no predictable pattern. And unfortunately here, I think this is going to fail. Notice that I can find a pattern here and that it looks like the dots start high, go low, and then come back up. Like they could almost be connected by a curve. So this right here does appear to have a predictable pattern. So I'll say here, there is a predictable pattern, and that's bad. Remember, if there's a predictable pattern, then that means that a line might not be the best shape because the errors that I'm seeing are predictable and therefore can be improved upon. So since there is a predictable pattern, I can state here that this means that a line, specifically a line, may not be the best shape to model the data with. So this is what I'm working with here. It doesn't seem like a linear relationship is the best. And hopefully this gives you an example of a time when I would get a residual plot that I would not be satisfied with. And this is a predictable pattern. Now to kind of show why I might be able to say that a line may not be the best shape to model the data, I'm going to go ahead and do something here, and I'm never going to actually ask you to do on any sort of homework or exam, but it is something to help illustrate the point of why this residual plot might be telling me that a line is not best. Really quickly, what I might see is that if I look back at this scatter plot, I might be able to imagine that maybe I could start to connect those dots with some sort of a curve, maybe something almost in like a quadratic or parabola type shape. And in fact, the calculator has the ability to double check this. Again, I'm never going to ask you to do this sequence of button pushes. I'm never going to ask you to do this ever. But let's take a look at how it would be done. I could go and click on Stat and Calculate. And you'll notice down here, I have an option for a quadratic regression. Like try to draw a parabola connecting a bunch of points. If I use list numbers 5 and 6 to do this, and I store the equation in the calculator so I can actually see it when I graph, I'm going to go ahead and put it underneath list number, or y number 2. Notice that the calculator can come up with the equation for some quadratic that can model the data. These are the values of a, b, and c that it believes should go in this formula. Notice underneath my y equals now, I'm going to have two formulas. I'll have one, that's my line of best fit, and another one here that's got an x squared in it. That's going to be my parabola. And notice if I hit the graph button now, if I go back to my scatter plot, and I hit the graph button. Hold on now, this has got to think. You can see the wheel up there spinning like it's trying to think really hard right now. Okay, so if I was to go and recreate now my scatter diagram as opposed to my residual plot, so let me just quickly update this to L6, what I can see is that I have my line that comes through here, and that's doing a pretty good job of modeling the data, but here's my new quadratic that's modeling the data, and I think it's pretty easy to see which one is doing the better job. This is why my residual plot was showing a pattern. It was indicating to me that there was a way that I could draw a different sort of shaped figure to better model the data, and this quadratic maybe is an improvement, or at least from the picture here, is definitely an improvement. All right, so I'm going to leave example B here as one for you to try on your own, but it asks the exact same set of questions and will allow you to practice making these 3 different types of pictures.